Okay, so a matrix is a rectangular arrangement of numbers into rows and columns. Notice I've given you a matrix that I've called matrix A. I've defined it as matrix A, and it looks like this. We put brackets around matrices, and we've got rows by columns. So notice that this matrix has 2 rows. Notice rows go horizontally. 1, 2, everybody see that? And then we have 3 columns. 1, 2, 3. Columns go down vertically. So the dimensions of a matrix are how many rows by how many columns. How many rows by how many columns. So since this matrix has 2 rows and 3 columns, we say that this is a 2 by 3 matrix. That's what we say. Okay? And then each number inside a matrix is called one of 2 things. We either call it an entry or we call it an element. So like this -2 right here, that would be either called an entry or an element. So each number in the matrix is called an entry or an element. So the dimensions, remember, the dimensions are rows by columns, never columns by rows, rows by columns. Okay, so I have here a few different types of matrices that have special names. The first one is called a row matrix. A row matrix is a matrix that only has 1 row. So let's determine the dimensions of this row matrix. Let's see, I see 1 row. So everybody see 1 row going across? And how many columns do I have? I have 1, 2, 3, 4 columns. So this row matrix, the dimensions of this row matrix is a 1 by 4. You see how I write that? 1 by 4. Okay, and then the next one is called a column matrix. A column matrix is a matrix that only has 1 column. The dimensions of this column matrix are 2 by 1. Notice there are 2 rows and 1 column. Does everybody see how that works? Okay, and then we also have something called a square matrix. A square matrix is any matrix that has the same number of rows as columns. Notice this matrix has 3 rows and it has 3 columns. So it's a 3 by 3 matrix, and it's also called a square matrix because it has the same number of rows and columns. And then a zero matrix is a matrix simply whose entries are all zeros. It doesn't matter what the dimensions would be, as long as the entries are all zeros, we call it a zero matrix. What are the dimensions of this matrix? We've got, let's see, 1, 2, 3 rows, and we've got 2 columns. So we've got a 3 by 2 here. Everybody see that? Okay, so that's just some special names of different types of matrices, and we can use those to practice naming the dimensions of the matrix. Okay, so here's something important. 2 matrices are equal, if and only if 2 things. 2 things have to be true. In order for 2 matrices to be equal, the dimensions have to be the same. And the second thing is that the corresponding entries have to be equal. Now remember from geometry, corresponding means in the same position. So the dimensions have to be the same. So notice these two matrices have the same dimensions. They're both 2 by 2. And also the corresponding entries are equal. So this number right here, -4/4, is in the same position as this entry over here, -1, and they're equal. So the corresponding entries are equal. So it's very important that we remember that for when we solve matrix equations, that how do we know when 2 matrices are equal? They're equal if 1, the dimensions are the same, and 2, the corresponding entries are equal. Okay, so now we're going to do a little bit of matrix operations. We're going to add and subtract matrices first. In order to add and subtract matrices, the dimensions must be the same. We cannot add matrices that do not have the same dimensions. So I can add this 3 by 1 matrix with this next 3 by 1 matrix. And this is the easiest thing in the world. All we're going to do is we're going to add the corresponding entries. When we add 2 matrices together, we just add the corresponding entries. So I'm going to say 3 plus 1 is 4. -4 plus 0 is -4. And 7 plus 3 is 10. And there you go. All right, let's look at the next one. We've got a 2 by 2 matrix that we want to subtract this other 2 by 2 matrix from. So my answer is going to be another 2 by 2 matrix, because we can only add and subtract matrices that have the same dimensions. So I'm going to say 8 minus 2 is 6. 3, be careful when you're subtracting, because sometimes we have to subtract a negative. 3 minus negative 7 is 10. Do you see how I'm subtracting the corresponding entries? 4 minus 6 is negative 2, and 0 minus negative 1 is 1. Easy enough? Okay, now what about this here? We want to add these two matrices together. Well, first we're going to look at the dimensions. We've got a 2 by 2 and a 2 by 1. So since these two matrices do not have the same dimensions, we're going to say that the addition is not possible. Okay, so the next operation that we're going to do is we're going to multiply by something called a scalar. A scalar in matrix math is any number that is outside a matrix. One more time, a scalar in matrix math is any number that's outside a matrix. So I can multiply a matrix by a scalar of 3. And the way that I do that is I multiply every single entry by 3. Very simple. We multiply every single entry by whatever the scalar is. So 3 times negative 2 is negative 6. I'm going to go across the row. 3 times 0 is 0. 3 times 4 is 12, and 3 times negative 7 is negative 21. All right, so the next example has a couple of steps here. We want to multiply the first matrix by a scalar of negative 2, and then we want to add the two matrices together. So we want to remember that in matrix math, order of operations still apply. In matrix math, order of operations still apply. So I'm going to multiply this first matrix by a scalar of negative 2 first, before I do anything with this other matrix. So I'm going to get negative 2, I'm going to get 4, I'm going to get 0 and negative 6, and then the third row I'm going to get 8 and negative 10. Now I'm ready to add the two matrices together. I'm going to check first to make sure that they have the same dimensions, and they do. I have a 3 by 2 matrix and another 3 by 2 matrix. So I'm going to add the corresponding entries. So I'm going to go across the first row. So I'm going to get negative 6. 4 plus 5 is 9. 0 plus 6 is 6. And negative 6 plus negative 8 is negative 14. Then I'm going to go across the third row. 8 plus negative 2 is 6 again. And negative 10 plus 6 is negative 4. Just checking my math to make sure I added correctly. Okay, so we want to remember when we do matrix math, order of operations apply. We multiply before we add and subtract, okay? And if we have grouping symbols like parentheses, we still apply that for order of operations also. Okay, so the last thing we're going to do is we're going to solve what's called a matrix equation. So we could look at two different things. First, we could look at a matrix equation where there's an equation that has matrices in it, but the variable is not inside the matrix. That's the first example here. Notice it says x minus a matrix equals another matrix. So obviously what we're going to do is we're going to add this matrix to the other side. So we're going to add this matrix to the other side to get x by itself. So I can do that. I can add a whole matrix to the other side. So I'm going to say x equals, and what I have here is one matrix plus another one. So I want to check first to make sure that they have the same dimensions. Do they have the same dimensions? We have a 2 by 2 with another 2 by 2. So we're going to add our corresponding entries. Negative 1 plus 3 is 2, 5 plus 5 is 10, 0 plus 4 is 4, and 2 plus 2 is another 4. And that's the solution. So in this case, the solution is a matrix. So when we solve a matrix equation and the variable is not inside the matrix, usually our solution is a matrix. Okay, and then we can also look at this equation. This one's a little different. Notice where the variables are. In this case, the variables are inside the matrix. So when we solve a matrix equation where the variables are inside the matrix, our answer is not a matrix. Our answers are actually numbers. What do those elements need to be so that this equation is true? So the first thing we're going to do is we're going to simplify both sides. We want to make sure we simplify both sides of the equation so that we have one matrix equals another one. So I'm not going to do anything to the right side yet. I'm going to simplify the left side, and I'm going to follow my order of operations. My order of operations says that we should do the stuff inside the parentheses first before we multiply by 2, or we could apply the distributive property and multiply each one of the matrices by the scalar of 2 first before we add them together. Either way is fine. I'm just going to add these two matrices together. So notice we've got a 2 by 2 with another 2 by 2. So we're going to add these matrices together. We're going to add our corresponding entries. I'm going to say 3x plus 4 is 3x plus 4, and that becomes one entry, even though it has a plus sign in it. And then negative 1 plus 1 is 0. And then I'm going to go across the second row. 8 plus negative 2 is 6. And 5 minus y is, 5 plus negative y is 5 minus y, isn't it? So we leave that as one entry, even though it has a minus sign. Okay, so now, I'm still going to keep simplifying. I'm not going to do anything to the right side yet, because that is only one matrix. I'm going to multiply the matrix on the left side by a scalar of 2. So I'm going to multiply every entry by 2. So I'm going to say 6x plus 8. That's my first entry. My next entry is 2 times 0, so that would be 0. Then I'm going to go across the second row. 2 times 6 is 12, and then 2 times 5 minus y would be 10 minus 2y. So what I've done is I've simplified both sides so that I end up with one matrix equals one matrix, and that's what we want. Because we remember that I said before that two matrices are equal if, what are the two things? Two matrices are equal if their dimensions are the same. Is that true here? And the dimensions are the same, and the corresponding entries are equal. So that's the most important thing we need to say here, is the corresponding entries are equal. So I want you to look here. This corresponds to that. Look, 0 and 0. Also, 12 and 12. Corresponding entries are equal. So what we know is this entry corresponds to this one, and since the two matrices are equal, those entries are equal. So I'm going to go over to the side, and I'm going to say 6x plus 8 has to be equal to 26. And I'm going to do the same thing with the y. I know that the 10 minus 2y has to be equal to its corresponding entry, which is 8. So I'm going to go over to the side, and I'm going to write a little equation. 10 minus 2y is equal to 8. And then I'm going to solve for x, and I'm going to solve for y. So I get x equals 3. 8 minus 10 is negative 2, so I get y equals 1. So that's what I do when I solve a matrix equation and the variables are inside the matrix. My solutions are going to be what x and y need to be so that that equation is true. So one more time, we get our equation simplified to one matrix equals one matrix, and once we get that far, then we know that the corresponding entries are equal. Okay, and then the last thing I want to add, and I didn't talk about this yet, is matrix addition is commutative and it's associative. So let's make sure we remember what that means, is that if matrix addition is commutative, then matrix A plus matrix B will be equal to matrix B plus matrix A. So if we turn them around and switch them around, it's still the same. And then associative means that if I have three matrices that I'm adding together, if I add the first two together and then add the third, that's going to be the same as if I add the second and the third and then go back and add the first. It's the same thing. So matrix addition is commutative and associative, and it's very important that we talk about that because we're going to start multiplying matrices together, and we're going to see that matrix multiplication is not commutative and associative, and we'll see that tomorrow. Okay.